Welcome to the new topic on compressors. The name itself clearly says compress, press. So, here the fluid can be pressed or the air can be pressed. So, we use this compressor at multiple places. For example, you want to push air into the cycle tube. You need to use a spray paint. In fact, when we try to use scent, we try to compress the gas and fill it inside a bottle. Whenever you press the knob, you get a spray of scent or aromatic air. So, compressor plays a part and parcel of many of the heavy machines. So, in this topic, we will try to understand basics of compressor, then what are the different types of compressor. We try to take only two compressors for the discussion. One is positive displacement compressor, the other one is dynamic compressor. Then we will try to see what is surging and choking in compressor, then intercooling. Finally, how do you calculate the efficiency of a compressor and few applications. Compressor is a device used to increase the pressure of a fluid. The fluid can be liquid or it can be air. While pumps perform a similar function for liquids and fan or blower are used for gases to achieve slight or moderate pressure increase. When you use a blower, there is an increase in pressure. But compressors are specifically designed to compress gas to very high pressures. So, you should understand, when we use a blower also you increase the pressure, but when you use a compressor it goes to very high pressure. This process involves supplying work to the device, typically through a rotating shaft from an external source. So, what we are trying to say is, you will have a motor which is attached to a compressor. So, that is what we say, typically through a rotating shaft through an external source. So, if you look at a typical compressor, there is a piston which compresses. When it compresses, it tries to pressurize air and the air is discharged. So, this is the outlet, and here suction. When the piston draws back inside a cylinder at a certain pressure, the suction valve will open and allow the air to go inside. In the same way, once there is a critical pressure reached, then the discharge valve will open and the air gets out. So, this piston is attached to a crankshaft. So, this crankshaft is in turn attached to a motor. Compressors, being a type of fluid machine that adds energy to the gas, falls into two broad categories. One is called as positive displacement compressor. The second one is called as dynamic compressor. In positive displacement compressor, you can get from a low pressure to a very high pressure. The capacity will be always constant. For a fixed capacity to get a varying pressure, we try to use positive displacement compressors. And dynamic compressors, where the capacity can be changed, the pressures can start from a higher value and it can drop down. Generally, what we do is we try to choose in this range where the capacity can be varied, the pressure is almost a straight line. So, these are the two big classifications of compressor: positive displacement compressor and dynamic compressor. So, now little bit of more understanding on this positive displacement compressor. These devices operate by trapping a volume of gas and then mechanically reducing that volume, forcing the gas to a higher pressure is done by a compressor. The process involves distinct volume change within a cavity. So, here it can be reciprocating type or it can be rotary type. The reciprocating type includes piston or plunger. When we talk about diesel injection, it is plunger, and when we talk about air, we predominantly look into a piston, and a diaphragm compressor. When we talk about rotary, they feature mechanism like sliding vane, screw and lobes. The operating principle for all this positive displacement compressor are they rely on volume change in a closed cavity to force the gas alone. So, this is what is shown here. They rely on volume changes in a closed cavity to force the gas along. A cavity opens to admit gas, then closes to compress, and then it exhales. The flow characters follows typically delivery, a pulsating or a periodic flow. So, naturally, if you want to have a continuous flow, you put an accumulator and then extract air. The viscosity handling, they can effectively handle a wide range of viscosity depending upon the fluid. For example, oil can be compressed. I was talking about scent can be compressed. Water can be compressed, right? Then you want to go to gas, it can be done. Steam can be done. So, viscosity of varying range can be done by using this positive displacement compressor. The flow rate control, the flow rate of PDC, positive displacement compressor, can only be varied by changing its displacement or operating speeds. Flow control, this can be done only by changing these things. So, here is a PV diagram wherein which it clearly demonstrates the function of a compressor. So, we can start from 1, this is the starting stage. So, from 1 I try to compress the air or the fluid, let us assume air here, I compress it to position 2. The action is compression, I use a compressor here. From 2 to 3 there is a discharge happening, there is a constant pressure, the volume is reduced. Then from 3 to 4 there is a pressure reduction falling down from 3 to 4, and there is a volume which is expanding. And again from 4 to 1 is suction. So, from 4 to 1 is called as the suction volume, from 3 to 1 is called as the stroke volume. The difference between suction volume and stroke volume is nothing but you have a small difference here, right. So, this is to be carefully handled. From 0, from this edge to 3, this one is called as the clearance volume, or from here to here is called as the clearance volume, which comes in the top. So, if you look at this PV diagram, it clearly demonstrates the compressor's function, what happens to the volume, what happens to the pressure. So, suction happens from 4 to 1, the piston moves down, drawing the gas at a low pressure and increasing the volume. It sucks, like when you try to pressure air, or when we try to do for, you try to suck the liquid inside a water gun cylinder. So, that is 4 to 1. So, there is at low pressures the liquid gets inside in water gun, here it is air, then it is compressed, then you try to compress 1 to 2, the piston moves up reducing the volume, because there can be volume front and there can be air. So, reducing the volume and increasing the pressure of the trapped gas. So, once you try to push it to a certain level, the droplet which comes out of your water gun or the small amount of air comes, till then it is compression, then it starts discharging. So, I try to press, there is a discharge of air, the compressed gas is expelled at a higher pressure as the piston reaches to the top end. So, you keep on be moving, so there is a discharge happening. The pressure reduction happens between 3 to 4. So, 3 there is a discharge happening, and there is a pressure reduction happening 3 to 4. The remaining gas expands back to the starting pressure, but within a small clearance volume that never leaves the cylinder. So, that is called as the clearance volume. 3 to 4, right? A small one. So, the next option, this is a straightforward simple thing. Let's try to understand dynamic compressors. These machines continuously add momentum to the gas through a fast moving blade or a vane. The high velocity imparted to the gas is then converted into pressure increase as it flows into a diffuser section. Friends, I am sure you will remember what is a diffuser. The high velocity imparted to the gas is then converted into a pressure increase, high velocity to a pressure increase as it flows into a diffuser section. Diffuser is this, diffuse. The rotary design, often called a rotodynamic compressor, that's what this dynamic compressor comes, includes centrifugal flow, axial flow, and a mixture of centrifugal and axial is the mixed flow. The operating principle will be they impart momentum to the gas using fast moving blades. We will see the figure, which is then converted into a pressure increase within a diffuser section. There is no enclosed volume involved in the compression process. So, the flow characteristics, it is generally provided a much steadier discharge. Viscosity handling, they are less effective with high viscous gas, and high viscous can significantly degrade their performance. So, this is a compressor. So, let me go back. So, the operating is they impart momentum to the gas using a fast moving blade. See here, there is a blade which is fast moving, which is then converted into a pressure increase within a diffuser section. This is a diffuser section, it is thrown out. Okay. So, there is no enclosed volume involved in the compression of the process as it happened in positive compressing. So, this is a blade assisted, which is rotodynamic compressor. You can also have centrifugal compressor. The air comes inside, the shaft rotates. So, the air gets thrown in and then it gets thrown out where the pressure increases. The other way around axial is there is something like suction happening from one end. You have a rotor which rotates and then you try to get the airflow outside. So, this happens in typically fan or in turbine blades. So, here is a plot which clearly shows the discharging pressure with the inlet flow. The dynamic compressor work by imparting velocity, which is known as kinetic energy, to the gas using a rotating impeller blade. So, this one. Then converting the velocity to pressure in a diffuser. So, the imparting velocity to the gas using rotating impeller blade, which then converts into a velocity to pressure in the diffuser. Now, the graph whatever is drawn here reflects this principle by showing a typical operating range. So, you can see here inflow, right? A typical operating range, the high flow, low pressure for a single stage, high pressure achievable with multiple stage. So, low pressure, high flow, low pressure for a single stage. Then it can be higher pressure achievable with multiple stage. So, you can have a single stage and a multiple stage compressor. So, the shape of the performance zone, broad horizontal range, limited vertical range, broad horizontal range, you can see here, broad horizontal range, limited vertical range, matches the fundamental behavior of the dynamic compressor, where a stable operation is maintained over a narrow pressure range at higher volumes. Clear? So, reciprocating compressor. A reciprocating compressor are a type of positive displacement compressor, PDC. Their fundamental principle involves forcing the gas along by changing the volume. So, the cavity opens to admit gas, then closest to mechanically reduce that volume, thereby squeezing the air to the high pressure before the expelling happens through the outlet. The mechanism results in pulsating or a periodic flow. So, this are the 4 stages of reciprocating compressor. So, 1 to 2 is the intake of air. So, the volume increases, pressure is almost constant. Then 2 to 3 is compression, which happens here in the position B, and then 3 to 4 is discharge, which happens C, right, and D is this, wherein which again the pressure reduces and the intake of the volume increases. So, 1, 2, 3, 4, A, B, C and D. So, now this is, we can also try to take this in the IC engine part for petrol engine. So, they deliver a pulsating or a periodic flow. If the outlet is shut off, they can generate immense pressure, necessitating sturdy construction and the use of pressure release valve to prevent the damage. The flow rate can only be varied by changing the displacement or the operating speed. This is for rotary compressor. Like reciprocating compressor, falls under the positive displacement rotary compressor. The working principle involves forcing the gas along by volume change within a confined cavity. So, here forcing the gas. So, you can see here the gas is getting sucked inside. So, that gets into a shell where this is a rotary. They try to compress it and through a relief. Right, you can see stage A, air coming in, stage B, how is the air coming in, and the rotary, the vane or the roller rotating piston. So, they try to move, rolling piston, they try to move to one side. So, they try to increase the pressure and then the air comes inside, further increase in pressure. At some stage, once the break even is reached, the discharge happens. The process involves a cavity opening to admit gas, then enclosures to compressor to expel it. It is similar to reciprocating, but the machine functioning is rotary. So, here also you will try to have pulsating and periodic flow. So, there are, as I told you, single stage and multiple stage rotors are there. The rotary compressor, the sources classify various rotary positive displacement mechanisms which are applicable to compressor when handling gases. Single rotary type and multi-rotary type are available. They include, single rotary includes sliding vane and a screw mechanism. When we talk about multiple rotary type, it includes gear, lobes and screw mechanism. These mechanisms trap and compress air through a continuous rotary motion. So, air inlet, so you can see air inlet coming in and then it is getting compressed and then you try to throw it out. So, this is the axial flow type. We saw the classification axial, centrifugal, radial. So, axial flow type, this is used in planes. Axial flow compressor forces gas to move axially through multiple stages. You can see there are multiple stages, low pressure turbine, high pressure turbine, high pressure compressor. Like centrifugal type, which was here, the centrifugal type, they are dynamic machines that add momentum to the gas. The gas passes through alternating rows of fixed stator and moves through a rotatory blade, each pair forming a stage. So, this point is important. Alternating rows of fixed stator and rotating moving rotor blades. This is stator moving rotor blades. So, alternating rows of fixed stator and moving rotatory blades, each forms, the stator and the rotor forms a stage. The rotor increases kinetic energy and the stator converts it into pressure while redirecting flow for the next stage. So, one stage moving to the next stage. Though each stage gives a small pressure rise, multiple stages adds significant value to the pressure increase. So, delta x plus delta x, delta x plus delta x, right. this equal to, it gives you a larger x, something like that. So each stage, multiple stage, each stage small pressure high, multiple stage a huge pressure high. So that's what is told here. So this is what typically happens. The air intake happens. This is the casing, and you have, these are the rotors, right? So moving blades in a rotating drum. So each one, this is a stator, rotor. So it compresses, pushes to the next, pushes to the next. Fixed blade in the casing you have. So there, whatever you get out is a compressed air delivery which happens, and this is a drive shaft. Surging and choking in compression. Surging, this occurs on a low flow side and is characterized by blade stall and vibration. So at the low flow side means in the intake itself it can happen. This occurs on the low flow side, surge, and is characterized by blade stalling and vibration. This represents an unstable operating condition, whereas the flow can reverse direction and lead to significant pressure and flow oscillation. Surge is something very, very important when we start working on turbines and compressors, right? It represents an unstable operating condition. It vibrates because at the low flow slide there is a stall which is happening, leading to significant pressure and flow oscillation. Choking is you try to block the flow. This phenomena occurs on a high flow side. Surge happens in a low flow side. Choke happens in a high flow side when the Mach number reaches 1 somewhere in the system. In compressible flow, where high velocity is comparable to the speeds of sound, density changes becomes significantly high. So when the Mach number goes to 1, the density change happens significantly. The choking signifies a sharp limit on the duct flow rate due to the sonic condition. So these two are to be avoided in a compressor. So when you try to see a typical compressor, pressure ratio versus mass flow rate ratio. Pressure ratio is inlet by outlet, mass flow rate is also there. So you can see there are 3 segments or 3 zones which are forming. So zone 1 is surging, unstable flow. Zone 2 is the useful flow, which is always tried to use, or this limit is used in compressor, and the last one is choking, which happens at the last. So A to B is the maximum pressure ratio point. So till it reaches the maximum pressure ratio point, the surging can happen, unsteady flow can happen. From there, the pressure ratio, you can see it falls down as and when the mass flow rate increases. So C, D, E till E, B to E, there is a reduction in the pressure ratio, but there is an increase in the mass flow rate ratio, right? Mass flow rate, it is increased. So after E comes the choking. So choking is actual maximum flow point. What is choking? Choking is here, where in the compressive flow, where the fluid velocity is comparable to sound, speed of the sound, density changes becomes significant. So that's why the mass flow we have done. And after that it falls down drastically. So this is the theoretical maximum flow rate point you can have, theoretical, but we always generally operate between B to E. So this image explains how a compressor works, especially what happens during surging and choking. Surging happens at low mass flow rate when the compressor tries to push against very high pressure. This is surging. The flow becomes unstable and can reverse direction, causing vibration and noise. So there is flow of air, there is a high pressure there. So this flow will try to push it back. So the flow becomes unsteady and can reverse the direction, causing vibration and loud noise. It is dangerous operating at condition. Compressor should avoid running at the surging point. Choking point at the right side of the graph happens at very high mass flow rate, where the compressor cannot push any more air through the flow hit its maximum limit. You are trying to throttle it, go to the maximum limit mass flow rate. At this point also the compressor fails. The pressure drop is very sharp and the compressor cannot increase flow any more further if you try, and the air moves so fast that increase speed does not help. So you reach a choking point, or this is called as choked maximum. Intercooling is very important because cooling a gas as it is compressed is highly desirable, as it significantly reduces the required work input to the compressor. When you try to pressurize air, there will be a lot of heat getting generated. That has to be cooled out. So, cooling a gas as it is compressed is highly desirable. Otherwise, what happens? The temperature phenomena comes. This temperature phenomena is going to rupture the casing, as it significantly reduces the required work input to the compressor. Multi-stage compressor with intercooling is a practical and effective technique to achieve the best out of it. The process involves compressing the gas in stages and cooling it between stages by passing through a heat exchanger is called as an intercooler. One stage compression, then before it moves, you cool it. So, the temperature falls down, but the rest pressure and velocity does not change. The intercooling and reheating always decreases the thermal efficiency of the cycle unless they are accomplished by regeneration. So, you are trying to cool or you are trying to extract heat. This extracted heat, if I can use it for some other purpose, then it is good. Otherwise, it is loss of thermal efficiency. This is because intercooling reduces the average temperature at which the heat is added to the cycle. So, this is a typical intercooling circuit you have. So, let us start from compressor, right. So, the compressed air inlet is going on. So, it is trying to pressurize the air. High pressure air is sent through the compressor to a charge air cooling. This is a heat exchange like a refrigerator. It passes through your refrigerator. So, the temperature heat air now becomes blue, cooled, and this cold air or the temperature reduced air is then passed into the inlet manifold of a machine. So, once there is a work done, there is a release of air with at a higher temperature. This goes into the compressor once again. So, from here it goes to the compressor once again. So, you can see here happening at one cycle this way, at one cycle this way. The heat or the hot air, the exhaust from the engine, that is what is called as engine exhaust gas. This gas goes to the compressor back. As and when it goes to the compressor back or to the turbine, so now air is pushed inside through the compressor. So, there is a mixing of fresh air and this happening, and then the system keeps continuing. So, you have exhaust manifold, intake manifold, exhaust manifold leading to gas, and there is a compressor which operates a turbine. So, this is done and then we try to use it. So, turbine inlet is here, turbine discharge is here, and then you try to get it. Intercooling is a very, very important stage. So, now coming to the last part of the discussion, where all can be the compressor used. The compressors are used in various engineering and industrial applications. You name it, IC engine, you name a DG set, diesel generator, or you try to call a train, then you try to call any processing industry. If you are using at home, we use a compressor. For your AC, we use a compressor. So, everywhere it is used. Some notable applications which are used is jet engines, rockets and spacecrafts. We also use compressors. The industrial facilities where compressed air is used for tasks like cleaning, operating pneumatic equipments and refrigerators. So, when you are trying to open and close in pneumatic system, compressors are used. The compressed air is used in a pneumatic system. The refrigeration and air conditioning system also we try to use compressors, wherein which it follows vapor compression refrigeration cycle. We have seen that. Gas turbine engines, they use compressors. Natural gas pipelines also they use compressors. Compressors are one of the major mechanical engineering system used in a real-time application. So, to recap, what we discussed in this chapter is we went through what are compressor, different types of compressor, positive displacement compressor, dynamic compressor, then two major situations which you will face in a compression cycle is surging and choking, and finally we saw the need for intercooling and where all are the applications of compressor. So, these are the references which are used for making these slides, and thank you very much.